students and viewers, welcome to video lecture session 15. In this, it is coming under third semester BSc Physics, and especially it comes under second unit. It is polarization and diffraction. My name is Lakshmi Narayana, Assistant Professor, Department of Physics, Government First Grade College, Vamadapadavu. Objectives of the present session is that the students will be able to understand the phenomena diffraction and various methods to obtain diffraction and the uses of diffraction. Session outcomes. After the discussion of the entire session, the students will be able to distinguish single slit and double slit diffraction patterns, and they can understand missing orders of double slit diffraction pattern due to overlapping of interference pattern in case of double slit diffraction. We require some basic details to understand completely the following session. The basic things are, first of all, diffraction definition and types of diffraction. Basically, it is the phenomena. The definition is that the spreading of light waves at an obstacle is called diffraction. One more definition: the encroachment of light in the sharp apertures is called diffraction. And there are two types basically. First one is Fresnel diffraction, second one is Fraunhofer diffraction. We don't go in detail about the differences of Fresnel and Fraunhofer diffraction. But one important thing is that in order to obtain diffraction, we need three things. One is source, and one is a slit or aperture, one is screen. So, in order to distinguish, we need to focus source and screen. In case of Fresnel diffraction, source and screen are near to each other. But in case of Fraunhofer diffraction, the source and the screen are very far from each other. This is the main difference. We need to focus Fraunhofer diffraction. In this case, the source and the screen are far from each other. We use lens to form Fraunhofer diffraction because whenever the source sends out rays, it passes through lens, sends out parallel rays. So it looks like the source must be from very far from each other if we use lens. So we use lens in this case. Next concept of Fraunhofer diffraction we need to understand at single slit and double slit. In case of single slit, a parallel beam of monochromatic light is incidenting on the single slit. It results secondary wavelets and are given out from all points in the plane and slit. The wavelets traveling along normal to the slit are brought to focus at a given point gives diffraction pattern. In case of double slit diffraction pattern, when here two slits are considered, diffraction pattern in this case has to be considered in two parts. First one is the interference phenomena due to the secondary waves emanating from the corresponding points of the two slits. Second one is the diffraction pattern due to the secondary waves from the two slits individually. So it is something different case, that is double slit diffraction. Here we obtain both interference phenomena, and it occurs both interference phenomena and diffraction phenomena in case of double slit diffraction. Then we have to focus on the main session details. Here you can observe a picture. In this top one is a graph represents the nature of variation of intensity on the screen for the case of single slit and for the case of double slit. Below is the actual picture we can observe on the screen. So it is a graphical representation. Along y axis intensity is there, along x axis position is there. Intensity is varying and it is maximum at the center of the screen, and it is gradually occurs, minima and maxima occurs on both the sides of the screen gradually, and unequal width alternating bright and dark bands are obtained. Next, in case of double slit, if we observe, full line represents equally spaced interference maxima and minima, and the dotted curve, you can observe dotted curve represents the diffraction maxima and minima in the region originally occupied by the central maximum of the single slit diffraction pattern. Equally spaced interference maxima and minima are observed. So this is the main difference between single slit diffraction pattern and double slit diffraction pattern. Let us go for in detail about the differences between single slit and double slit diffraction pattern. In that, first one is the main difference between diffraction pattern is that double slit diffraction pattern is the superposition of the two phenomena, that is single slit diffraction pattern and interference pattern. So this is the first difference. You can observe once again the picture. Second difference, the principal maximum of a double slit pattern envelopes a number of interference maxima and minima. In between the diffraction pattern, you can observe interference maxima and minima. The intensity, third one is the intensity of the principal maximum of double slit diffraction pattern is about 4 times as compared to that of single slit. Once again, the intensity of the principal maximum of double slit diffraction pattern is about 4 times as compared to that of single slit. Next difference is that the spacing of diffraction maxima and minima depends on the two factors. One is width of each slit, that we consider here is A, and the spacing of the interference maxima and minima depends on the value of A and B, where B is the opaque spacing between these two slits. B is nothing but the distance between the two slits. So first thing, the spacing between diffraction maxima and minima depends only on A, and the spacing of the interference maxima and minima depends on the value of A and B. Next is the intensities of the interference maxima are not constant but decreases to 0 on either side of the central maxima. these intensities of the interference maxima are not constant but decreases to 0 on either side of the central maximum. So this is about the differences. Next thing is missing orders in a double slit diffraction pattern. First thing, direction of the interference maxima are given by the equation a plus b sin theta is equal to n lambda. Let us consider it as equation 1. The direction of the diffraction maxima are given by the equation a sin theta is equal to p lambda. Directly I am considering here. It once again it requires basic knowledge of interference and diffraction. With that we use the formulas, the two formulas. In the above equation we know what is A and B. A is the slit width and B is the spacing between two slits. Theta is the angle. Lambda is the incident monochromatic light wavelength. And n and p are just integers. That means n is equal to 1, 2, 3, 4, etc. number. P is also an integer. It is like 1, 2, 3, etc. whatever it may be the value. So they both are just integers. Here if the values are such that both the equations are satisfied simultaneously for the same value of theta, then the position of certain interference maxima correspond to the diffraction minima at the same position on the screen. See, once again we have to consider first equation represents the direction of interference maxima, second equation represents the direction of diffraction minima. So for the integer, for the same two integer values we can observe missing orders. Let's see in detail about it. First case, let us consider if A is equal to B, then 2a sin theta is equal to n lambda, first equation, and a sin theta is equal to p lambda is the second equation. First equation represents the interference maxima and second equation represents diffraction minima. If we divide 1 by 2, we obtain n is equal to 2p. N by p is equal to 2, then n is equal to 2p. It is not mentioned in the PPT, but if you solve 1 by 2, you will be getting n is equal to 2p. That is the condition in this case, first case. If p is equal to 1, 2, 3, etc. if we consider, then n changes to the values 2, 4, 6, etc. If p is equal to 1, 2, 3, etc., then n changes to 2, 4, 6, etc. because there is a condition that n is equal to 2p. So the orders 2, 4, 6, etc. of the interference maxima will be missing in the diffraction pattern. So as a result of the condition A is equal to B, finally the orders 2, 4, 6, etc. of the interference maxima will be missing in the diffraction pattern. Let us consider the second case. Here, if suppose 2a is equal to b, then equation interference maxima condition becomes 3a sin theta is equal to n lambda, and diffraction minima equation becomes a sin theta is equal to p lambda. Again, if we divide 3 by 4, we obtain n is equal to 3p. That is the condition here. Then if p is equal to again 1, 2, 3, etc. if we consider, then n is equal to 3, 6, 9, etc. So in this case particularly the orders 3, 6, 9, etc. of the interference maxima will be missing in the diffraction pattern. Next is the condition. Suppose if a plus b is equal to a, that means to say that b is equal to 0. That means there is no space between the two slits, it becomes a single slit. So the two slits become a single slit. So it is the case of a single slit diffraction. As already told you, in case of single slit diffraction there is no interference occurs. So here it is the case that the two slits join and all the orders of the interference maximum will be missing. The diffraction pattern observed on the screen is similar to that due to single slit diffraction of width 2a. So this is about the main content in the following session. Let us just recapitulate the things that we discussed. Single slit and double slit diffraction pattern. Single slit, in case of single slit we only obtain diffraction pattern. In case of double slit we obtain diffraction in addition to interference in addition to diffraction phenomena. There are some major things in single slit and double slit diffraction pattern: intensity and graphical representation, etc. Once again, if we just go for the diagram that you can observe completely, this is the main graphical representation. So once again, if we observe the graphical representation, you can remember the things that we discussed. See, in case of double slit diffraction, there is an overlapping of interference fringes in the diffraction diffraction fringes. Let us just go for again to the things. Missing orders in a double slit diffraction pattern, it is due to the same theta value under the two equations and the integer values. If we maintain the conditions for the slit width and the distance between the two slits, that is A and B, we can observe some missing orders in the diffraction pattern in case of double slit diffraction pattern. Let us just discuss some multiple choice questions. First question is, in case of single slit diffraction pattern experiment, the width of the slit through which light passes is reduced. What happens to the width of central bright fringe? Is it stays the same, it becomes narrower, it becomes wider? Its behavior depends on the wavelength of light. Answer is it becomes wider. In width of the slit through which the light passes is reduced. As a result, the slit central bright fringe becomes wider. Second one, what is it called when a trough and a peak meet at the screen? It is first option, constructive interference, destructive interference, diffraction interference and special interference. So it is nothing but diffraction interference. It is for the case of double slit diffraction pattern. Third one is, for which condition diffraction patterns observed on the screen is similar to that due to a single slit of width? For which condition diffraction patterns observed on the screen is similar to that due to a single slit of width? That is when A is equal to B, second option A is equal to 2B, third option B is equal to 2A, fourth option A plus B is equal to A. So answer is D. When A plus B is equal to A, B is 0, then there is a overlapping of the two slits, then it becomes a single slit of width 2a. So the option D is correct. So this is about the following session details. Further reading, you can go for 3 books. One is Optics by Ajay Ghatak. Second one is Fundamentals of Optics by Jenkins and White. Third one is a textbook of optics by B.K. Mattar. Thank you.